All right, trying to find the magnitude and the directional angle of the given vector v. Okay, and as we can see, the v is written in two different forms here. We're written in trigonometric form and linear combination form. This one is very pleasant because the way you write this is you say the magnitude of the vector times the directional angle times, the cosine of directional angle and the sine of directional angle multiplied times the I and the j. It's a very convenient form. So, this is going to give you the length of the horizontal direction. This will give you the length of the vertical direction. But anyways, so this is like doing extra work here is kind of unnecessary. Here is your magnitude, and here's your magnitude for each of those. And the directional angle, that's going to be the 60 degrees, and this one's going to be the 135 degrees. All right. The one that requires a little bit more thinking is the ones that are written in linear combination form. Okay, so if it's written in linear combination form, I mean, if you've been studying this, you know that this is also the component form of this guy. And if you wanted to find the magnitude of it, what you're going to have to do is you're going to have to square the first term, square the second term, and take the square root of that. That will give you the length of our vector. Now, we derive this length or magnitude formula, if you will, from the Pythagorean theorem. In this case, it's going to be 36 plus 36. We're going to have to take the square root of that, so 72, the square root of that, and I believe that might even simplify. No, I can't think of anything that might. Oh, you know what? It does simplify because we have two 36s in there. We could split that up to be 36, square root of 36 times the square root of 2. So it would be 6 square root of 2. This is going to be our magnitude for this guy. And if we wanted to find a directional angle, we're going to have to bust out tangent. Tangent theta of, let's draw a picture so we can remember. If we have 6 and then negative 6, that would be 1, 2, 3, 4, 5, 6, okay? And negative 6, 1, 2, 3, 4, 5, 6, okay? So this is where our vector would be. If this was the angle right here, which we know is theta, the way we would find that is we would take this length right here, which is negative 6, and then divide that by this length right here, right? Y divided by x, or in this case, this would be the b, and this would be the a, because we're talking about vectors. This is the a, and this is the b, so we're going to say negative 6 divided by 6, which is negative 1. So what is the theta if we are in the fourth quadrant, and tangent equals negative 1? And I'm hoping you're saying 315, because that would be right. So this would be 315 degrees, and that is your directional angle for that one. So in short, we're going to have to use tangent theta b divided by a to find theta. Okay, and then we're going to have to use the distance formula, that is a squared plus b squared, and square root that, or the magnitude formula, to find the magnitude for number 49 and 50. It's not as obvious as 47 and 48.